Let's rewind to the days before the world turned digital. Back then, minuscule amounts of data were generated at a relatively sluggish pace. All the data was mostly documents, and in the form of rows and columns. Storing or processing this data wasn't much trouble, as a single storage unit and processor combination would do the job. But as years passed by, the internet took the world by storm, giving rise to tons of data, generated in a multitude of forms and formats every microsecond. Semi-structured and unstructured data was available now in the form of emails, images, audio, and video, to name a few. All this data became collectively known as big data. Although fascinating, it became nearly impossible to handle this big data, and a storage unit processor combination was obviously not enough. So, what was the solution? Multiple storage units and processors were undoubtedly the need of the hour. This concept was incorporated in the framework of Hadoop that could store and process vast amounts of any data efficiently using a cluster of commodity hardware. Hadoop consisted of 3 components that were specifically designed to work on big data. In order to capitalize on data, the first step is storing it. The first component of Hadoop is its storage unit, the Hadoop Distributed File System, or HDFS. Storing massive data on one computer is unfeasible. Hence, data is distributed amongst many computers and stored in blocks. So, if you have 600 megabytes of data to be stored, HDFS splits the data into multiple blocks of data that are then stored on several data nodes in the cluster. 128 megabytes is the default size of each block. Hence, 600 megabytes will be split into 4 blocks, A, B, C, and D of 128 megabytes each, and the remaining 88 megabytes in the last block, E. So, now you might be wondering, what if one data node crashes? Do we lose that specific piece of data? Well, no. That's the beauty of HDFS. HDFS makes copies of the data and stores it across multiple systems. For example, when block A is created, it is replicated with a replication factor of 3 and stored on different data nodes. This is termed the replication method. By doing so, data is not lost at any cost, even if one data node crashes, making HDFS fault-tolerant. After storing the data successfully, it needs to be processed. This is where the second component of Hadoop, MapReduce, comes into play. In the traditional data processing method, entire data would be processed on a single machine having a single processor. This consumed time and was inefficient, especially when processing large volumes of a variety of data. To overcome this, MapReduce splits data into parts and processes each of them separately on different data nodes. The individual results are then aggregated to give the final output. Let's try to count the number of occurrences of words taking this example. First, the input is split into 5 separate parts based on full stops. The next step is the mapper phase, where the occurrence of each word is counted and allocated a number. After that, depending on the words, similar words are shuffled, sorted, and grouped. Following which, in the reducer phase, all the grouped words are given a count. Finally, the output is displayed by aggregating the results. All this is done by writing a simple program. Similarly, MapReduce processes each part of big data individually, and then sums the result at the end. This improves load balancing and saves a considerable amount of time. Now that we have our MapReduce job ready, it is time for us to run it on the Hadoop cluster. This is done with the help of a set of resources, such as RAM, network bandwidth, and CPU. Multiple jobs are run on Hadoop simultaneously, and each of them needs some resources to complete the task successfully. To efficiently manage these resources, we have the third component of Hadoop, which is Yarn. Yet another resource negotiator, or Yarn, consists of a resource manager, node manager, application master, and containers. The resource manager assigns resources. Node managers handle the nodes and monitor the resource usage in the node. The containers hold a collection of physical resources. Suppose we want to process the MapReduce job we had created. First, the application master requests the container from the node manager. Once the node manager gets the resources, it sends them to the resource manager. This way, Yarn processes job requests and manages cluster resources in Hadoop. In addition to these components, Hadoop also has various big data tools and frameworks dedicated to managing, processing, and analyzing data. The Hadoop ecosystem comprises several other components like Hive, Pig, Apache Spark, Flume, and Scoop, to name a few. The Hadoop ecosystem works together on big data management. So, here's a question for you. What is the advantage of the 3x replication schema in HDFS? A. Supports parallel processing. B. Faster data analysis. C. Ensures fault tolerance. D. Manages cluster resources. Give it a thought and leave your answers in the comment section below. 3 lucky winners will receive Amazon gift vouchers. Hadoop has proved to be a game changer for businesses, from startups and big giants like Facebook, IBM, eBay, and Amazon. There are several applications of Hadoop, like data warehousing, recommendation systems, fraud detection, and so on. We hope you enjoyed this video. If you did, a thumbs up would be really appreciated. Here's your reminder to subscribe to our channel and click on the bell icon for more on the latest technologies and trends. Thank you for watching, and stay tuned for more from Simply Learn.